Hello, welcome to question number 6. So 6a, Roshi is doing a study on the electricity use in houses across a town. Roshi selects a random sample of 16 houses for the study. State the population of the study. So this will be all houses in the town. Or alternatively, it could be all houses that use electricity in the town. Give one reason why Roshi uses a sample. Well, because it's cheaper, or it's easier, or it's quicker. Okay, so rather than doing a population where he'll be looking at every single person and it will take him forever, he's using a sample to get the work done. Okay, 6C, 5 marks for this. The average electricity use per day in kilowatt hours is normally distributed with a mean of mu and the variance of 1.7. Here is the average electricity use per day in kilowatt hours recorded by Roshi at the 16 houses. So use these values to construct a 95% confidence interval for mu. So the first thing that I'm looking at doing is I'm going to find the mean. So adding up all of these 16 values and then dividing by 16, it's 141 over 16, which gives me 8.8125. Now, if you struggle with these confidence interval levels, do just get the mean. Get the mean so that you're able to at least pick up 1 mark. Now, the standard deviation is going to be the square root of the variance, which then gives you 1.304. Now, to work this out, we need to have the mean plus or minus our standard error, which is z, times by the standard deviation divided by the square root of n. So our mean is 8.8125. Our z value for our 95% confidence interval level is 1.96. So we are going to plus or minus the 1.96 multiplied by 1.304 over the square root of 16, which is actually the square root of 4. Okay, put those into your calculators. For the add version of the answer, the top end, we've got 9.45, and for the takeaway part, we've got 8.17. So I'd be writing it as 8.17 to 9.45. Okay, right. Part C, part 2, Roshi realizes he has made a mistake. Each value recorded is 0.5 kilowatt hours less than the actual value. So that's going to increase every value by 0.5. So that means we're going to add onto our interval level by 0.5, which gives us 0.67 and 9.95. Okay, Roshi decides to use a larger sample of houses. Now, in our formula, where we've got the standard deviation divided by the square root of n, that value is going to be bigger, which makes the overall thing smaller, which means that then when that's multiplied by the 1.96, you get a smaller number. So instead of having the interval level out here, this value becomes a little bit narrower, and therefore your confidence width will decrease. Okay, that's question 6 all done. Let me just make sure there's not another little bit on here. No. So we're on to question 7 next, and I'll see you at that video. Bye-bye.